Quality.
Go.
Op Safety Manager.
Go.
ULA Safety Officer.
Go.
Vehicle System Engineer.
Go.
Anomaly Chief.
AC is go.
Range Coordinator.
Clear to proceed.
Launch Director.
You have permission to launch.
Proceeding with the count.
And as you heard, Launch Conductor Ed Kidda has received a go from all stations to continue the countdown. We're scheduled to release the hold in about 1 minute, 45 seconds, and countdown to an on-time liftoff of the United Launch Alliance Atlas V rocket and NOAA's GOES-S spacecraft at 5:02 p.m. Eastern Standard Time.
Still minus 5 minutes, 30 seconds.
Start list data capture.
Roger.
NSC, verify spacecraft on internal power.
Spacecraft is on internal power.
All steps complete prior to terminal count.
The GOES-S spacecraft configured for launch on internal power. Everything is go. 5 minutes away from launch. We have 45 seconds remaining in this hold. Plan to come out of the hold and launch at the opening of a 2-hour launch window at 5:02 p.m. Eastern Time. NASA Launch Manager Tim Dunn just reporting to Launch Director that NASA is go for launch as well.
On my mark, the time will be T minus 4 minutes and counting.
4, 3, 2, 1. And we are at T minus 4 minutes and counting.
After launch, we'll be hearing the voice of United Launch Alliance's Marty Malinowski providing a status of the flight of the Atlas V and NOAA's GOES-S.
At launch minus 2 minutes, the Atlas and Centaur power will be internal.
Ground pyros have been enabled. Liquid oxygen securing and liquid oxygen topping are underway. Atlas tanks will be pressurized to flight pressure at T minus 3 minutes. Shortly thereafter, the flight termination system will go internal.
Atlas tanks to flight pressure.
Securing LO2 topping.
250.
FTS internal.
Following Atlas and Centaur power to internal at T minus 2 minutes, the ground launch sequencer will command the launch sequencer to start at T minus 1 minute 55 seconds. T minus 2 minutes 14 seconds and counting.
$159.
Vehicle internal.
155.
Launch sequencer start.
And the Atlas and Centaur power is now internal.
Centaur LH2.
Securing Centaur LO2.
The flight termination system will be armed at T minus 1 minute 37 seconds.
7.
FTS armed.
We are 1 minute, 30 seconds to launch.
The environmental control system will be reduced for launch at T minus 1 minute 15 seconds.
1 minute, 20 seconds.
OCU's armed.
SES count started.
115,
Reduce ECS for launch.
Roger.
110,
Vent valves locked.
The vent valves are closed on the Centaur, liquid oxygen and liquid hydrogen vent.
T-minus 1 minute.
Rock, report range status.
Range green.
Range Operations Controller reports range green. Everything is go. T-minus 51 seconds and counting.
T-minus 40 seconds.
Stable at step 3.
Closing in on 30 seconds before launch. 3 seconds before launch, the powerful RD-180 engine will ignite.
Go on.
Roger.
25.
Status check.
Go Atlas.
Go Centaur. Go.
Everything is go. T-minus 15 seconds and counting.
9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES will reach Mach 1, traveling faster than the speed of sound.
Down, right on schedule. Signatures look good. Roll program is complete. The speed chamber pressures are rolling off as expected.
At 47 seconds after launch, the vehicle will pass through the area of maximum dynamic pressure, or max Q.
Max Q.
This is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the Earth's atmosphere.
Booster has throttled up as expected.
You are also hearing the voice of United Launch Alliance flight commentator Marty Malinowski.
SRB chamber pressures continue to look good, have plateaued.
At 1 minute 50 seconds into flight, the first 2 solid rocket boosters will be jettisoned, followed about a second and a half later by
burnout.
other boosters.
And we have indication of SRB burnout. Booster engine continues to perform well. Approximately 10 seconds to SRB jettison. And we have indication of 4 solids jettisoning. Looks like a clean separation.
And a clean separation being reported of the solid rocket boosters.
Vehicle
We are
has
2
begun
minutes,
closed
4 seconds into
steering.
flight.
The next major milestone, 3 minutes 30 seconds into flight, the payload fairing protecting GOES during its flight through the atmosphere will be jettisoned 3.5 minutes after launch.
Booster has throttled down as expected. Up on the RCS pyro valve activation. We have the RCS pyro valve activation at this point. The system is pressurizing to flight levels. Signatures look good.
Three minutes into the flight.
And booster has throttled back to 2.5 Gs. Preparation for payload for jettison.
Ten seconds away from payload fairing jettison.
Up on payload for jettison momentarily. And we have good payload for separation and CFR jettison.
And we have a good payload fairing jettison, exposing GOES-S to space for the first time.
Signatures look good.
We are approaching 4 minutes into flight.
And booster has begun to throttle to 4.6 Gs in preparation for pico. Boost phase cooldown is underway. Logo pyro valve has been fired.
The call BECO stands for Booster Engine Cutoff. That will happen at 4 minutes 22 seconds into flight.
Boost phase chill down is complete. And we have pico. Shutdown looks good.
6 seconds after BECO, the Centaur second engine, or second stage will separate from the Atlas booster.
Booster. The RL-10 engine. GN2 purge firing. The RCS is underway. We have ignition and full thrust on the RL-10.
And the Centaur single-engine RL-10C engine ignites for the first time. It produces 22,900 pounds of thrust.
Our steering has been enabled. Fire rates look good.
This is about a 7.5 minute burn of the Centaur
PU
RL-10C engine.
Fixed angle, as expected.
Engine cutoff planned for about 7 minutes from now. This is the first of 3 burns of the Centaur main engine.
Continue to warm towards bottle temperatures. Signatures look good. Centaur PU has gone to closed loop control. Current range track shows Centaur making good headway down the middle of the corridor. Current altitude is 129 miles. Downrange distance is 701 miles. Current velocity 13,903 miles per hour.
Listening to the voice of United Launch Alliance flight commentator Marty Malinowski describing the flight of the Atlas and Centaur.
Performance shows basically a nominal booster. Beginning to see the RCS thermal conditioning firing. Signatures look good. RL-10 continues to perform well. Chamber pressures, lax pump discharge, and fuel venturi, all appropriate for the mark.
We're 7 minutes into the flight of GOES-S. Another 5 minutes remaining in this first burn of the Centaur single engine.
Very small loss of data. As resumed, all signatures look good across the dropout. Current altitude is 146 miles. Downrange distance 1094. Current velocity is 14,685.
Eight minutes after liftoff, and everything continues to go well.
We have about 4 more minutes left in the burn of the Centaur main engine cuts off. That would be called MECO 1.
Oxidizer-rich condition. DC, ox pump discharge, and fuel venturi all look good. Centaur tank pressures remain stable. Storage bottle pressures look good. Batteries are also good. Body rates controlling right down the middle. Track continues to show good progress down the middle corridor.
3 minutes remaining in this burn of the Centaur engine.
Centaur main engine burn continues to look very good. Chamber pressures, ox pump discharge, and fuel vent 3 all within expected parameters.
And we are 10 minutes into flight.
Hydrazine line temperatures have nearly achieved bottle outlet temperatures at this point. Continue to see light RCS firings. Still running slightly oxidizer rich at this point in the burn. A little less than 2 minutes remain in this burn. All systems look good. And Centaur is now commanding a nominal MR, having worked off the excess oxidizer error.
About 1 minute remaining in this burn of the Centaur main engine.
Centaur main engine continues to look good.
Standing by for the first of 3 burns of the Centaur main engine to cut off, also known as MECO 1.
Good. 4S settling motors on. CRDs have been safed.
And we have MECO.
Fuel tank pressures have been vented down.
About 12 and a half minutes into flight. We'll be in a coast phase for about the next 10 minutes prior to relighting the Centaur second stage engine for the second of 3 times today.
Centaur has continued its turn to MES 2 attitude.
From Atlas Launch Control, I'm here with Scott Messer, United Launch Alliance Program Manager. Scott, thank you for coming.
Thank you.
Yes, sir. And tell us a little bit about how this launch is going so far.
Well, so far it is going almost perfectly. The count was very quiet today. In fact, probably the quietest count that I've been through. Actually, from a personal note, the only real big excitement for me was the birth of my fourth grandson this afternoon at T-minus 3 hours and 30 minutes.
Well, congratulations.
Yeah, so that's exciting for me. But the count was very quiet, and so far met all the milestones. Everything is looking good.
And so far for this year for United Launch Alliance, this is your third launch in 2018.
It is our third launch, it's a great year. It's a big, busy year for NASA, and we've got a lot of interesting missions working with NASA. The GOES mission, of course, is our third mission this year, as you said, and we've at United Launch Alliance actually launched every GOES mission that has ever launched since 1975. So it's very exciting. We're in the middle of a 3-minute the first coast now. We'll go into a 5-minute burn after that, and then we'll go into a 3-hour coast where we put GOES into the geostationary transfer orbit. Some fun facts. As we finish the second burn, the vehicle will be traveling about 22,000 miles per hour. To put that in perspective, that would be about 7.5 minutes coast to coast from LA to New York. So it's moving pretty quickly. And at liftoff, the vehicle weighed about 1.2 million pounds. We have about 2.25 million pounds of thrust that gets the vehicle going. And as I said, we're excited to be part of the GOES mission. It's a great mission for the nation, and helps a lot of people with improved weather predictions.
And so after GOES is in its orbit, what's next for United Launch Alliance?
So as I mentioned, we've got a very busy year with NASA. Coming up in May, we've got the InSight mission, which will be the first Mars mission to ever launch from the West Coast. So that's an exciting activity. Followed on in July 31st with Parker Solar Probe mission that will touch the sun. And then finally we'll end out our year with NASA with our last and final Delta II mission, the ISAT mission out of Vandenberg in September. So it's a busy year for us and a lot of excitement coming up.
Well, thank you very much for joining us today, and congratulations on launch so far, and also your other news.
Yes, thank you very much.
Yes, sir. Thank you for being with us.
All right, thank you.
Center has achieved a 60% 4S duty cycle at this point. Signatures look good.
"19 minutes, 22 seconds into the flight of GOES-S. Everything continues to go well as the Centaur upper stage ferries GOES-S to its final destination in space, standing by for the second stage engine restart at a mission elapsed time of 22 minutes 38 seconds. So about 3 minutes from now.
And Centaur has gone to 100% for us settling in preparation for S2. Tank pressures are being increased as well. One minute to S2.
And 1 minute before the
going to dual
Centaur
branch
second stage ignites again. GOES will eventually be in a geosynchronous orbit, which is an orbit that keeps the satellite over a specific location on Earth. By maintaining a hovering position over a fixed point on Earth's surface, GOES are able to constantly monitor atmospheric conditions in a particular portion of Earth's atmosphere.
"30 seconds away from the Centaur second stage engine restart." Again, this is a burn. We'll hear the call from Marty Malinowski.
Box restart. We have ignition and full thrust on Aero 10. This burn is currently scheduled for a duration of 350.5 seconds.
And as you heard, we have a good main engine start. 2.
U has been enabled and currently commanding in oxidizer-rich condition. Chamber pressures, box pump discharge, and fuel venturi all look good.
This burn will last about 5 more minutes.
Hydrazine lines are at bottle temperatures at this point. Tank pressures look good. Storage bottles and batteries are as well. Centaur's current altitude is 112 miles, downrange distance 5,470 miles, current velocity 18,544 miles per hour. Continue to see our RCS thermal conditioning clearance. Signatures look good.
We are 24 minutes, 30 seconds into flight. The RL-10 engine continues to fire during its second of 3 burns.
So are performing as expected.
Three minutes remaining in this burn of the Centaur main engine.
EU continues to control near nominal, having worked off the excess oxidizer. RL-10, these look very good at this point in the burn. Two minutes remaining of this burn. All systems continue to look very good. Operating as expected. Burn altitude, 132 miles. Downrange distance, 6,291 miles. Velocity, 20,954 miles per hour.
GOES has successfully traversed the Atlantic Ocean, and as you can see, is now making its way along the west coast of Africa. Continuing its ascent and its eastward trek to its final destination in space later this evening when it reaches its geosynchronous transfer orbit.
Seconds to MECO. RL-10 continues to look good. MR controlling near nominal. RCS line temperatures look good. We have MECO. Shutdown looks good. We have Forest Subline.
And there is one more burn remains before NOAA's GOES separates. The third and final burn takes place after a nearly 3-hour coast phase.
So with the successful Centaur engine cutoff and the beginning of the long coast phase, we will now turn things back over to Tori, and later this evening we'll be back here at Atlas Launch Control. Tori?
Thanks, guys. We'll see you after the coast phase. The GOES series features important technology upgrades and advancements. Blair Allen from NASA Edge is on set with NOAA's Jim Yo, Chief Administrative Officer for the Joint Center for Satellite Data Assimilation. Blair?
Thanks so much, Tori. Jim, first thing I got to ask you is, tell me, what did you think of the launch?
Well, this is my first launch live. It was really exciting, I got to say. But I'll tell you the truth, I'm even more excited about the work that's coming up for me and my colleagues putting these new data to work for better forecast and warnings for the American public.
Well, it's interesting because John Leslie, who works for NOAA, told us you were the weather satellite expert. So I imagine from your perspective, with all these new advancements, you have to be very excited about the things that you're going to be able to do now that when GOES becomes operational.
Absolutely. And of course, we started seeing some of the promise of this from GOES-R. We saw the benefits that we were hoping we would get from having the advancements from the advanced baseline imager with more channels, allowing it to differentiate more features in the atmosphere and on the ocean and land surface, from having better resolution that could help us, see the fine structure of storms and wildfires and any number of things like that. And finally, having the rapid scanning that, 5 times as often as the previous generation of GOES that help us see the evolution of storms and give more timely warnings.
Well, okay, now speaking of that,